Here are a few more examples from section 6.3 using quadratic formula. Now remember, this can be used then to solve any quadratic equation. So as we talked about yesterday in class, oops, sorry about that. Trying to get my pen up here. All right, as we said yesterday in class, we can go ahead, we can use completing the square if the leading coefficient is 1 and the b term is even. That is when it's best to go ahead and use completing the square. For everything else then, quadratic formula will work wonderfully. So let's take a look at this example then. I want to go ahead, again, these are the ones we did not do in class yesterday, so these are just more practice. So I want to go ahead here, I want to take a look at this one. Alright, this is to solve the quadratic equation x squared plus x minus 20 equals 0 using the quadratic formula. Now, as I said yesterday in class, the example will be broken up into two parts, one in which we will use I will tell you what technique to use, and in the other you can use whatever you would like. Alright, so first question is this in standard form? And that is yes. Now, if we were in the free-for-all section where you could use any technique you would like, I would recommend factoring this because it's quicker and easier. But since we're asked to use the quadratic formula, we should go ahead and do so. Now, as a reminder, I will not be giving you the quadratic formula on the test, so it's something you will need to know. I would begin by identifying what your a, b, and c is. Remember, a is the coefficient of your x squared, b is your coefficient of x, and c is your constant term, or the number at the end. Again, please make sure you are in standard form when you take a look at this. Now, the best way then to commit the quadratic formula to memory is to write it out over and over and over again. Alright, so that is going to be then a negative b plus or minus b squared minus 4ac, the entire expression over 2a. Be careful not to use just the radical. Now, substituting in then, that'll be a negative 1 plus or minus m, the square root of 1 squared minus m4 times 1 times our c value, which is then going to be all over 2 times 1. Now remember, the radical acts as a grouping symbol, so you will need to perform the operations underneath the radical first. And we're going to go ahead and jump up here. So this then gives me negative 1 plus or minus n, the square root of 81, all over 2. And then the square root of 81, as you're well aware, is 9. Now, since we can combine what is up on the top, remember this does give us two solutions. We can separate it apart into negative 1 plus 9 over 2 and negative 1 minus 9 over 2. This then gives me 8 over 2, which is 4, so one of my solutions is 4. And over here then, that's going to give me then negative 10 over 2, which is a negative 5. So there then are my two solutions of a positive 4 and a negative 5. Alright, again, I'm going to make a note, if you need to pause to look at something, to review where I'm pulling a number from, please pause the video or rewind it. That's a nice part about these videos, is you can rewind me like you can in class. Okay, so let's take a look then at this next one here. I have to solve the quadratic formula x squared minus 4x minus 8 equals 0 using the quadratic formula. Now, if this was me, if this was in the free-for-all section, since this has a leading coefficient of 1 and the middle term is even, I would actually use completing the square on this one. Alright, but since we're being asked to use the quadratic formula, we should go ahead and do so. Now again, I'm going to begin this project by identifying what my a, b, and c is. Oops. Alright, bumping here with my wrist. Remember, a is the coefficient of x squared, b is our middle term, and c is our constant. Again, our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over then 2a. Now watch your signs. This negative sign is part of the formula. So that's going to be then a negative 4 plus or minus n, the square root of a negative 4 squared, minus n4 times 1 times the 8. This will then be all over 2 times my a value, which is 1. A minus is going to change this into a positive 4. Simplifying then the inside there, I have a negative 16, then minus 32 all over 2. I'm going to go ahead and jump up here. This then gives me 4 plus or minus then the square root of a negative 16 over 2. Now remember, we're not changing any of the rules of a radical. So you're going to simplify the negative square root of 16 as to a 4i. Now again, we have a polynomial over a monomial here, so that 2 has to go into both parts. So that's going to be 4 divided by 2, which is 2, and then 4i divided by 2, which is 2i. So we then have our two solutions of 2 plus 2i and 2 minus then 2i. And again, we want to make sure that these expressions are in lowest terms. All right, fantastic. All right, let's take a look then at the next one, okay? Now, in this one then, I want to go ahead, I want to solve negative 3x squared minus 11x minus 20 equals 0. Now, we're almost in standard form, but remember, to be in standard form, our a, or our leading coefficient, has got to be positive. So to accomplish that then, I'm going to go ahead and I'm going to divide then both sides by a negative 1. This then gives me the equivalent formula of 3x squared plus then 11x plus 20 equals 0. Now, I know some of you then will say, well, can't I just leave it like that? Technically, you can. All right, there's nothing wrong with it, but with all the other techniques we have, it's just easier if you always remember to put it in standard form first. So again, then I'll make my A3, my B11, and then my C20. Now from here then, we can go ahead and plug this then into our formula. So this will become then a negative 11 plus or minus then the square root of 11 squared minus 4 times 3 times 20. Again, please watch your signs as you are doing this. This will then be all over 2 times 3. This then becomes negative 11 plus or minus 121 minus 12 times 20 is 240. Oh, there it goes. All over then 6. And then I should have grabbed my calculator to have on hand here, but I was like, oh, I can do this. Alright, so very quickly, that's going to be then 119 if my arithmetic is correct. So again, jumping up here, let's go ahead, let's erase that pen mark I have. Okay. This then becomes a negative 11 plus or minus then the square root of a negative 119 all over then 6, which then gives me a negative 11 plus or minus I. 119, I believe, is a prime number if my memory serves me correct. It's not divisible by 2, 3. I think we're good. Alright, so that's going to be then I square roots of 119 all over then 6. So we still have our two solutions of a negative 11 plus I square roots of 119 all over 6, and then negative 11 minus I square roots of 119 all over 6. Again, if you need to pause, please pause. If you need to rewind, please rewind. If you have questions, please feel free to go ahead and to email me. All right. Very good. All right. We're going to do one more in this video, and then I'm going to separate the rest of them into a second video just to keep things easier and short. Okay. So let's look at this one then. I have 2x squared minus 5x plus 8 equals 0. Okay. Again, first check, we are in standard form. Alright, so we can begin then by identifying my A, my B, and my C. So that's going to be then 2, negative 5, and a positive 8. And again, the quadratic formula is a negative b plus or minus the square root of b squared minus 4ac all over then 2a. Now again, let's watch our signs. That's going to be then a negative 5 plus or minus then a negative 5 squared minus then 4 times 2 times 8. Again, watch those signs. This then gives me over 2 times 2. So this then becomes 5 plus or minus then the square root of 25. Minus 8 times 8 is 64. All over then 4. And then I can jump it back up here. Gotta love those arrows, right? This becomes then 5 plus or minus n, the square root. 64 minus 25, really quick, is 39. All over then 4. And then the factors of 39 are 1 and 39, 3 and 13, and that is it. So that means then that that's our